Now we'll start with another chapter of integration called as advanced trigo of integration. So we will start with integration, advanced trigo. Some authors even call it as substitution trigo. Let's see the sums. Integral of x raised to n minus 1 tan x raised to n dx. Right? Let us see how do we do this sum. Let us assume let x raised to n be equal to t. Differentiate with respect to x. d by dx of x raised to n is nx raised to n minus 1 is dt by dx. Therefore, you will get dx is dt upon nx raised to n minus 1. Now, I can say I is equal to x raised to n minus 1 tan t dx can be written as dt upon nx raised to n minus 1. X raised to n minus 1, x raised to n minus 1 gone. 1 upon n integral of tan t dt, which can be written as 1 upon n log mod sec t plus c. We substitute the value log mod sec t. T can be written as x raised to n plus c. Let's see another sum, guys. Integral of cosec tan inverse of x upon 1 plus x square dx. Now let's see this. You will say let tan inverse of x be equal to t. Differentiate with respect to x. d by dx of tan inverse of x is 1 upon 1 plus x square, which is equal to dt by dx. Therefore, you can say that dx is nothing but 1 plus x square dt. I is equal to integral of cosec t upon 1 plus x square. Dx can be written as 1 plus x square dt. Now this is nothing but integral of cosec t dt. Integral of cosec t is log mod cosec t minus cot t plus c. We substitute the value of t. So this is log mod cosec t. T can be written as 1 plus x square minus cot 1 plus x square plus c. Right? Let's see another sum, guys. Integral of sine x minus a upon sine x plus a dx. Right? Very important sum, very interesting sum. The degree of polynomial is same in the numerator and denominator. Since the degree of polynomial is same in the numerator and denominator, you will introduce the denominator in the numerator. So this will be integral of, first let's write the denominator as it is, x plus a, leave the function as it is, introduce the polynomial x plus a. I have introduced the denominator in the numerator, but I need x minus a and I have x plus a, so this can be written as x plus a minus 2a dx. Now this can be written here, I can expand this by using addition formula. Sin a minus b is sin a cos b minus cos a sin b upon sin x plus a dx. This can be written as split the numerator. Sin x plus a cos 2a upon sin x plus a dx minus integral of cos x plus a sin 2a upon sin x plus a dx. Now sin x plus a gets cancelled. This is cos 2a integral of dx minus sin 2a integral of cos x plus a upon sin x plus a dx. This can be written as cos 2a integral of dx is nothing but x minus sin 2a. The term in the numerator is the derivative of the term in the denominator. dy dx of sin x plus a is nothing but cos x plus a. The term in the numerator is derivative of the term in the denominator. So I could use the formula. Integral of f bar of x upon f of x is log mod f of x plus c. I could use this formula. If I use this formula, this will be nothing but log mod sin x plus a plus c. So your final answer will be x cos 2a minus sin 2a into log mod sin x plus a plus c. Next, let's see the next one, guys. Integral of sin x upon cos x minus a dx. Right? Let's see this. Again, the degree of polynomial is same in the numerator and denominator. Since the degree of polynomial is same in the numerator and denominator, introduce the denominator in the numerator. I have introduced the denominator polynomial in the numerator. Remember, you have got to do nothing with the function. Leave the functions as it is. Just introduce the denominator polynomial in the numerator. Now there is only x here and I have written x minus a. To keep the equation constant, I will write plus a. I can expand this by using addition formula. Sin a plus b is nothing but sin a cos b plus cos a sin b upon cos x minus a dx. This can be written as split the numerator sin x minus a cos a upon cos x minus a dx plus integral of cos x minus a sin a upon cos x minus a dx. Now here I could take cos a constant outside. Dy dx of cos x minus a is minus sin x minus a. To make the numerator to be the derivative of the denominator, I will multiply by minus sign outside and inside. So now my numerator becomes derivative of the denominator. So this will be log mod x minus a plus this and this cancels. Sin a integral of dx is nothing but x plus c log mod cos x minus a. Right? So log mod denominator plus sin a into x plus c. That will be your answer. Let's move on to the next one, guys. Integral of dx upon sin x minus a sin x minus b. Right? Let us see how do we do this sum. Now, for the timing, let's forget the sum. Let us consider what is x minus a minus x minus b. If I were to just take this term and simplify this is x minus a minus x plus b, which would be nothing but b minus a. Now, let's see the sum. I can say I is equal to integral of dx upon sine x minus a sine x minus b. Whenever you have multiplication of two similar trig ratios, you have to multiply and divide by sine of constant. If you have two similar trig ratios, you have to multiply and divide by sine of constant. So this is going to be, I'm going to divide by sine b minus a. I'm going to multiply by sine b minus a upon sine x minus a sine x minus b dx. This can be written as 1 upon sine b minus a. I can say b minus a. Right in the beginning we said that b minus a is nothing but x minus a minus x minus b. So this can be written as x minus a minus x minus b upon sine x minus a sine x minus b dx. This can be written as 1 upon sine b minus a integral. You can expand this by using addition formula sine a minus b, which is nothing but sine a cos b minus cos a sine b upon sine x minus a sine x minus b dx. This can be written as 1 upon sine b minus a, split the numerator. So this can be written as sine x minus a cos x minus b upon sine x minus a sine x minus b dx minus integral of cos x minus a sine x minus b upon sine x minus a sine x minus b dx. Right? Now, here sine and sine gets cancelled. Here also sine and sine gets cancelled. This is 1 upon sine b minus a. Now, d by dx of sine x minus b is going to be nothing but cos x minus b. That means the term in the numerator is derivative of the term in the denominator. Therefore, this is going to be log mod of denominator. Guys, I am using the formula integral of f bar of x upon f of x is log mod f of x minus log mod sine x minus a plus c. But log a minus log b is nothing but log a minus b. So this is going to be log a minus b is nothing but log a upon log b. So x minus b upon sine x minus a plus c. That will be your answer. Right? Remember, if you have similar trig ratios, if you have product of similar trig ratios, if you have sine into sine or cos into cos, then you divide and multiply by constant. Right? I'll show you another sum where you do not have similar trig ratios. Let's see another sum, guys. Integral of dx upon sine x minus a cos x minus b. Right? Same thing that you did in the previous sum. Consider x minus a minus x minus b is nothing but x minus a minus x plus b, which is nothing but b minus a. Now I is integral of dx upon sine x minus a cos x minus b. In the previous sum you had similar trigo ratios. In this sum you have dissimilar trigo ratios, right? Your trigo ratios are sine cos, right? When you have similar trigo ratios, you had multiplied by sine, multiplied and divided by sine of the constant. When you have dissimilar trigo ratios, you will divide by cos of constant. You will divide by cos, multiply by cos. This is sine x minus a cos x minus b dx. Now this can be written as 1 upon cos b minus a integral of cos b minus a can be written as x minus a minus x minus b. Right in the beginning we proved this, upon sine x minus a cos x minus b dx. I can expand this by using addition formula. I can expand this by using addition formula. Cos a minus b is nothing but cos a cos b plus sin a sin b upon sin x minus a cos x minus b dx. Split the numerator. So 1 upon cos b minus a integral of cos x minus a cos x minus b upon sin x minus a cos x minus b dx plus integral of sin x minus a sin x minus b upon sin x minus a cos x minus b dx. Right? Now this can be written as 1 upon cos b minus a. Cos and cos gets cancelled. D by dx of sin x minus a is cos x minus a. So you will use the formula integral of f bar of x upon f of x is log mod f of x. So log mod of denominator plus, here sin and sin gets cancelled. D by dx of cos x minus b is minus sin x minus b. Now in order to get that minus sign, I am going to multiply by minus sign outside and inside. So minus into minus gives me plus. Now because of this minus sign, the term in the numerator now is the derivative of the term in the denominator. So this will be minus log mod cos x minus b plus c. This can be written as 1 upon cos b minus a. This is log a minus log b is log a upon b. X minus a upon cos x minus b plus c. Fine. This finishes the sum. Let's move on to the next sum, guys. Integral of sin x plus a cos x minus b dx. Again, a very similar sum to what we did a couple of sums ago. The degree of polynomial is same in the numerator and denominator. That means I have to introduce the denominator in the numerator. Leave the function as it is, x minus b. I want x plus a, I have written x minus b. So plus b plus a. That way my equation remains constant. So I have introduced the denominator in the numerator. I can expand this by using addition formula. Sin a plus b is sin a cos b plus cos a sin b upon cos x minus b dx, right? Split the numerator, so this will be sin x minus b cos a plus b upon cos x minus b dx plus integral of cos x minus b sin a plus b upon cos x minus b dx. Now dy dx of cos x minus b is minus sin x minus b, multiply by minus outside, multiply by minus inside. That way the term in the numerator will become the derivative of the term in the denominator. Constant comes outside the integral sign and multiplies with this minus. So minus cos a plus b. Since the term in the numerator is derivative of the term in the denominator, it will be log mod denominator, right? Plus cancels, constant comes out, a plus b. Integral of dx is nothing but x plus c. That will be your answer. Let's see another sum, guys. Integral of dx upon square root of 1 minus sin x. Nice sum. Now let's just consider first 1 minus sin x. 1 minus sin x can be written as cos square x by 2 plus sin square x by 2. Cos square theta plus sin square theta is 1 minus sin x by using sum multiple can be written as 2 sin x by 2 cos x by 2. Now this is in the form a square minus 2ab plus b square, which will be nothing but a minus b the whole square, right? Now therefore I could say that square root of 1 minus sin x is going to be square root of cos x by 2 minus sin x by 2 the whole square. Square and root gets cancelled, so that will be cos x by 2 minus sin x by 2. Now multiply by root 2, divide by root 2. Why? I'll just show you. I'm multiplying by root 2. I'm going to divide by root 2. Cos x by 2. I'm dividing both the terms by root 2. Sin x by 2. Right? Now 1 upon root 2 can be written as sin 45. 1 upon root 2 can also be written as cos 45. So this can be written as root 2. This 1 upon root 2 I am writing as sin 45. 45 can be written as pi by 4 cos x by 2, and this 1 upon root 2 I am writing as cos 45. Either way you could have written sin x by 2. Would not make a difference. Now this is in the form sin a cos b minus cos a sin b. By using addition formula, this is nothing but sin a minus b. That means root of 1 minus sin x is root 2 sin pi by 2 minus x by 2. Right? Let us see this. I can therefore say I, which is integral of 1 upon root of 1 minus sin x dx, can be written as integral of 1 upon root 2 sin pi by 2, pi by 4 this should be, guys, sin pi by 4 minus x by 2 dx. Root 2 is constant, comes out, so 1 upon root 2, 1 upon sine is nothing but cosec pi by 4 minus x by 2 dx. Right? Let's continue that sum up there. Now integral of cosec theta is nothing but log mod cosec theta minus cot theta. So this is 1 upon root 2 log mod cosec pi by 4 minus x by 2 minus cot pi by 4 minus x by 2. Whatever is the number multiplied with x has to come in the denominator, divided by minus 1 by 2 plus c. Right? Now, root 2 and 2 gets cancelled to give you root 2 here. Denominator of denominator becomes numerator. So the answer will be minus root 2 log mod cosec pi by 4 minus x by 2 minus cot pi by 4 minus x by 2 plus c. Nice sum. Let's see another sum, guys. Integral of dx upon 2 sin x plus 3 cos x. Right? Now I have different numbers here, totally non-related numbers. When you want to bring relationship between such numbers, the easiest method is to draw a right angle triangle. 90 theta. Assume any side to be 2, the other side to be 3. Let's apply Pythagoras. If I apply Pythagoras, this will be root 30. If I apply Pythagoras, my hypotenuse will come out to be root 30. I can say I is integral of dx upon 2 sin x plus 3 cos x. Multiply by root 13, multiply the denominator by root 13, divide the denominator by root 13. So this is going to be 1 upon root 13. I have multiplied the denominator by root 13. Now I am going to divide the denominator by root 13. 2 by root 13 sin x plus 3 by root 13 cos x. I have multiplied the denominator by root 13. I have divided the denominator by root 13. Now 1 upon root 13 integral of dx upon 2 by root 13 from the triangle can be written as opposite upon hypo. So this will be sin theta. So this is sin theta sin x plus 3 by root 13 can be written as cos theta cos x. This can be written as 1 by root 13 integral of dx upon, you could use addition formula here, cos A cos B plus sin A sin B is nothing but cos A minus B. Right? Now this can be written as 1 by root 13 integral of 1 upon cos is nothing but sec x minus theta dx. Integral of sec theta is log mod sec x minus theta plus tan x minus theta plus c. But from the right angle triangle, I can say that theta, guys, from the right angle triangle, theta, tan theta is nothing but opposite upon adjacent. That means tan theta is 2 by 3. That means theta can be written as tan inverse of 2 by 3. So I am going to substitute this as tan inverse of 2 by 3 plus tan x minus tan inverse of 2 by 3 plus c. That will be your answer, right? I think that was the last sum of this chapter. This finishes this chapter. Let's stop here for the day. Thank you.